Hey guys, this video is going to be about acid-base reactions and determining the product for those. Alright, so acid-base reactions are also called neutralization reactions, and when an acid is added to a base or the base is added to an acid, they can neutralize each other to form water. Alright, so if you remember, acids always start with an H, and bases always produce OH or have OH in them. So if we have one H and one OH, we make an H2O. And so that's how they always make water. The production of the water is the driving force of the reaction. So when a reaction occurs, something has to change in the reaction chemically. What changes in the reaction during an acid-base reaction is the production of liquid water, because acids and bases are aqueous. So the production of the liquid water is the change that drives the reaction. Same with a gas-evolving reaction. The production of the gas is the driving force. A precipitation reaction is the production of the solid, the precipitate. So there's always something driving the reaction forward, causing the products to be formed. All right, so it's always acid plus base, or you can write base plus acid, it doesn't matter. And it's always going to give you some sort of salt, and a salt is just an ionic compound. An ionic compound is always going to be a metal that has a positive charge plus a nonmetal. And nonmetals typically have a negative charge. So you have this positive and negative. Those are ions. This is the cation. This is the anion. So those two together form the salt. All right, and so this one of the most popular introductory acid-base reactions is hydrochloric acid, and sodium hydroxide produces NaCl, that's table salt, and then liquid water. So I'm going to rewrite this first one so I have enough room. So barium hydroxide plus HF, and we want to determine what's formed. So I know that this is a base, and I know that this is an acid. So I'm going to write down the ions here that each of them form. So this would be barium 2+, and we also have hydroxide, 1 negative. We have hydrogen and fluoride. So if I'm going to pair up outside with outside and inside with inside, I'm going to get barium fluoride and then water. So barium fluoride would be BaF2, right? Just real quick, this is 2+, and that's 1 negative. Crisscross applesauce, we get barium fluoride. And then I would also have H2O. It does not matter about this 2. You're always going to make water, okay? H5O3 is not a thing. All right, H3O2 is not a thing. So you can't write that down. You have to balance the equation after you have written the products. So now I can go back and balance this reaction. I've got 2 fluorides right here, so I need 2 of these. And now I have 2 hydrogen, and I also have the 2 hydroxide right here. So if I have 2 hydrogen and 2 hydroxide, so if this up here at the very top of the screen, this and this make 1 water, if I had 2 of these and 2 of these, that would make 2 waters. So I'm going to need 2 waters over here. So now this reaction is balanced. Okay, let's do the next one. So next I have HC2H3O2, which is acetic acid, and that's going to be reacting with potassium hydroxide. So I'm going to do the same thing. I'm going to look and see what ions I have. So this is a hydrogen ion plus an acetate, and then this is potassium ion and hydroxide. So I'm going to react outside with outside, inside with inside, and I'm always going to make sure that I put the positive ion, the cation first. So if I have a hydrogen and a hydroxide, that's going to make water. And then if I have potassium and acetate, that's going to make KC2H3O2. Since they're both, since potassium is +1 and acetate is -1, then it's just a 1-to-1 ratio, and this one is already balanced. All right, now the last one, we've got nitrous acid and sodium hydroxide. So I've got H plus nitrite, sodium, and hydroxide. So again, I'm going to go outside with outside and inside with inside, and that's going to give me water and sodium nitrite. Okay, and so these are all liquids, and then these are all aqueous, and then these are all aqueous. So even if your acid is weak, it's still aqueous. All right, so here it says when a strong acid or strong base is in solution, they dissociate completely. This allows the hydrogen ions from the acid and the hydroxide ions from the base to react together to form water. So we're going to look at ionic equations of acid-base reactions. This is very similar to the ionic equations that we wrote for the precipitation reactions. So it's really not that different. All right, we have hydrochloric acid, sodium hydroxide, we get table salt and water. And so that's called the molecular equation, right? It's just your typical reaction. And then we have the complete ionic equation, where if it's a strong acid, remember it completely dissociates in water, right? It's a strong electrolyte, so it completely dissociates in water. And then we have a strong base here, so it completely dissociates in water. Sodium chloride is a strong electrolyte. Sodium ions are always soluble. So I get sodium ion and chloride ion, it completely dissociates. And then we have liquid water, which doesn't completely dissociate because it's liquid. All right, and so we have a net ionic equation here because my spectator ions are going to be the chloride ions, the sodium ions, because they haven't changed, right? They're the same on both sides. So if we cancel those out to get our net ionic equation, if you have a strong acid and strong base, it will always be hydrogen reacting with hydroxide to give water. But weak acids and weak bases are weak electrolytes, and they do not dissociate completely. So they only dissociate when they're in the presence of strong base or strong acid, so you do not dissociate them in complete ionic equations. When we look down here at this one, we have hydrofluoric. This is a weak acid. And we have rubidium hydroxide, which is a strong base. So we end up with rubidium fluoride and water. If we look at this, we have to keep this weak acid together. It does not break up like the hydrochloric acid did in the example above. Oops, I have sodium here. This should be rubidium. My bad. It's probably a copy-paste error. All right, so rubidium hydroxide, on the other hand, is a strong base, and so it dissociates into rubidium ions and hydroxide ions. And then rubidium fluoride, since this is an alkali metal, it dissociates completely into rubidium and fluoride. And then we also have water, and it doesn't dissociate. So when we go down to write our net ionic equation, the ones that are going to cancel out are the ones that are on both sides of the reaction. So rubidium is the only spectator ion here. So we cancel those out, and we end up with HF plus OH gives fluoride and water. And this is a very, very, very important concept for equilibrium of acids and bases when we talk about titrations. What I want you to look at and notice the difference is between these up here and these down here. Since this was a strong acid plus a strong base, the only thing that you see is hydrogen and hydroxide in the net ionic equation. Since this was a weak acid and a strong base, you still see the weak acid down here, but you only see hydroxide because the cation canceled out as a spectator ion. So remember not to dissociate those completely and just drop them down, and then cancel out your spectator ions to get your net ionic equation. First example is calcium hydroxide and hydrobromic acid. So I'm going to check these. Both of this is a strong base. This is a strong acid. I get calcium bromide, right? And that's just looking at the ions. Calcium's +2, bromide's -1, and I get water. And I'm going to go ahead and balance this. This is aqueous. I'm going to go ahead and balance this So I have 2 of these because of this 2. And then I have 2 H's and 2 OH's, so that's going to make 2 waters. All right, and if I wanted to write the complete ionic equation for this, then that would be calcium plus 2 hydroxides plus 2 H plus 2 Br minus, calcium 2 plus 2 bromides plus 2 waters. This is the only thing that's liquid. All of the ions are aqueous. Ions are always aqueous in these kinds of reactions. We have calcium ions. It's a spectator, right? Because it's on both sides. And the bromide ions are spectator because it's on both sides. So we end up with 2 hydroxides plus 2 H plus goes to 2 H2O. And we could even cancel out those 2's. So if you just had to write the net ionic equation and you realized that you had a strong acid and a strong base, you could just skip all of the complete ionic equation. Next, we're going to have acetic acid plus lithium hydroxide goes to lithium acetate plus water, right? So all I did was write down the reaction, and I know that this is H plus, this is acetate, this is lithium, and this is hydroxide, so I put outside with outside, inside with inside, and then I can get my products from that. You will get faster at that as time goes on. It just takes knowing the ions and doing it for a little while. All right, so for my complete ionic equation, I need to check and see which ones are weak acids and which ones are strong bases or acids. So this one is going to be a weak acid, and this one is a strong base, right? This is a strong electrolyte here because lithium is in the first group and alkali metals are always soluble completely. So I end up with HC2H3O2. It stays together because it's weak. It's still aqueous. All acids are. And we get lithium ion, hydroxide ion, lithium ion, acetate ion, and we get liquid water. My spectator ions are going to be the lithium ions, so I'm going to get rid of those. And for my net ionic equation, it's going to be HC2H3O2 plus hydroxide, just get rid of those spectator ions. And remember, this is called the complete ionic equation. And for the last example, we have HClO2 plus NaOH goes to, and what we would end up getting if we did outside with outside, inside with inside, is sodium chlorite and water. All right, and so for my complete ionic equation, since this is a weak acid and this is a strong base, then I know I have to dissociate the sodium hydroxide but leave the chlorous acid together. So this is aqueous. Sodium ions, hydroxide ions, and we get sodium ions, chlorite ions, and water. So my spectator ions are the sodium. And for my net ionic equation, I'll have HClO2 plus hydroxide goes to ClO2 plus H2O liquid. All right, so again, when it's strong acid, strong base, you're just going to have hydroxide, hydrogen, and water. But when it's a weak acid and a strong base, you're going to have the weak acid will remain together, the strong base will dissociate. We'll talk about what happens with weak bases in the big acid base unit because they're a little bit different.